So the final piece of the puzzle here is just to evaluate Java monitor object synchronized methods. And we're going to use our running example here. I think you'd agree with me that it's much better to not have race conditions than to have race conditions, no matter how inefficient things are. So that's a step forward. It's better than what we did with BusyQueue. So BusySynchronizedQueue is certainly better than BusyQueue. Hooray, hooray. However, as I've also alluded to multiple times, synchronized methods can be limited when they're used in isolation. And that's because we've got these busy wait problems. So if this is full, it won't be corrupted. It'll just keep looping somewhat neurotically. And that could be a problem. Now, if you're writing the inner control loop for a nuclear reactor temperature gauge, and you've got to find out whether the nuclear reactor is too hot or too cold on a nanosecond basis, busy waiting could be for you. Of course, if you're writing a nuclear reactor temperature gauge control system, please don't use Java, right? Use something else. Use C, because you're probably going to be in trouble when the whole thing decides to garbage collect at an inopportune moment. But the point is that that's the downside. Now, there are times when it's useful to use busy waiting, but not always. So that's the main problem. What we really need to do is we need to coordinate calls so that we don't busy wait when there's nothing to do. Now, what we really want to do, and we'll see this when we talk next, in the next class, when we talk about the coordination mechanisms that are provided with Java built-in monitor objects, we want to have some other methods besides offer and pull. And in fact, they're going to be called put and take. And they're going to provide the coordination, and then they can use offer and pull or not as the implementation mechanisms when the conditions are right to make forward progress. So that was just a segue to the wait and notify mechanisms, the coordination mechanisms that are part of Java built-in monitor objects. And we will talk about the simple bounded blocking queue. I'm not sure why it says simply bounded blocking queue. That is not correct. I'll fix that too. It should be simple bounded blocking queue. And that's going to end up using the intrinsic condition property of Java built-in monitor objects in order to have threads queue up when they're unable to make forward progress to add or remove elements from the blocking bounded queue. So that's the end of our evaluation of synchronized methods and by extension synchronized statements. They're an important partial solution, but they're not the whole story.